know how to do. Some of it I'm showing you because I want to show you sort of a different way to go about it, sort of a different trick. Now, there are some of them that you'll have to do my way because there's no other way to do them. And then there are some sort of like that, the distributive property one, where you've got some choices. You don't have to do it by getting rid of the negative 2. You could distribute. So I'm not going to require you to do it my way, but I want you to write down my way so that you can sort of get used to using it, because sometimes it does make it easier. So let's say, or let me share a couple of things about equation solving in general with you. Couple different analogies that go along with equation solving. You all know that equations have to be balanced, right? So anything you do to one side, you have to do to the other. You're probably pretty used to that. I like to think of solving an equation like opening a present, okay? It's like the math gods took this letter, they took this variable, they hid a number behind it, and they put it in a box. And then they wrapped it up with order of operations, okay? So they followed order of operations, PEMDAS. So first they did parentheses, then they did exponents, then they did multiplication and division, then they did stop that. Then they did addition and subtraction. Okay, they did all of those things, and so now it's wrapped up in this box. Okay? You have to undo that. You have to do everything that they did in reverse. Okay? So you're unwrapping that variable to find out what it is. So, that's right. So, you're used to using PEMDAS as your order of operations. Guys, you're going to want to jot this down. That's right. For equation solving, you're doing everything backwards. So you are undoing everything in reverse order. So you're going to hear me say SADMAP.
Why?
What's SADMAP? Where am I getting that from?
Asked Dad.
Where did I get that from?
My entire project.
It's PEMDAS backwards, right?
Oh, it is.
So when you're equation solving, first you're going to get rid of subtraction and addition. Then you're going to get rid of division and multiplication. Then you're going to get rid of exponents. And the last thing you're going to get rid of is parentheses. Okay? So you're just going to hear me refer to that along the way. So let's look at number 1. 1/4 x minus 3. Question, Olivia?
Yeah.
Go ahead.
So we're just like throwing everything like we know about PEMDAS away because we have to do it backwards.
No, you're not throwing it totally away. If I gave you a math problem to do, like if I said I wanted you to do 2 plus 3 times 5, and I wanted you to get the answer to that, that's where PEMDAS is going to apply. An equation is like someone has already done that, and you're trying to undo it to figure out what that x was to begin with. Okay, so this is specific to equation solving. And it's really, you've been doing this a long time. Probably you've just never had any crazy teacher call it SADMAP. Okay? But you'll hear it from me a couple of times throughout the year. Okay, so let's look at 1/4 x minus 3. What's the first thing you would get rid of here?
Subtraction.
Okay, so let's get rid of the subtraction with the opposite of subtraction, which is addition. So I'm going to add 3, and I get 1/4 x equals 13. How do you get rid of 1/4?
Divide by 1/4.
Okay, here's the thing. Stop right there for a second. You could divide by 1/4, but dividing by fractions is ugly. Okay.
Ugly.
By 4.
Okay.
God doesn't like us.
Okay, lots of great ideas floating out here, and I've heard a lot of right things. Hold on just a second. Okay. You could turn it into a decimal. Now, something like 1/4 is going to make a nice, pretty decimal. It's going to make 0.25. That's fine with me. That is one way to go about it. When you get down to something like 2/3, that does not make a pretty decimal. Okay? You've been having so much fun, I know. So decimals work sometimes, but not always. If you divide by a fraction in your calculator, you've got to remember to put the fraction in parentheses, which is just one more place that you could possibly make a mistake. So I would get rid of it, and I heard lots of you say it. I know Michaela said it, I think Olivia said it, or maybe Austin, I don't remember.
The voices are the same.
No, I just don't remember. I don't remember. I'm going to multiply by the reciprocal. What's the reciprocal of 1/4?
4/1.
4/1, which an easier way to say that would just be 4. Yep. So I'm going to multiply by 4, multiply by 4, and I get x equals 52.
You're in 5.5%.
This is so confusing.
Did you just do 52
Just
in
think.
your head?
Yeah.
The fish
It's a great question. We're going to get to that in number 2.
Why can't you
Okay, let me help you with that.
do the reciprocal first?
Great question. You could do the reciprocal first if you wanted to. If you did like, why didn't we start by multiplying by 4 over 1?
Yeah.
We could have. If I did that, though, I would have to make sure I multiply this 3 by that reciprocal, too. So that is another way to do it, though. If I had 1/4 x minus 3 equals 10, and I wanted to get rid of it with that fraction right off the bat, which I'm going to do when we get down to, like, number 3, okay? If I wanted to get rid of that right off the bat, I could multiply everything in the equation by that reciprocal right away. That's going to cancel that out and just give me an x. The thing that people forget when they're doing that is they forget that this 4 needs to be multiplied by the 3 as well. So that's going to make that a 12. And then that's going to make 4 times 10, that's going to be a 40 there. So you could start with it as long as you remember to catch that number in the middle. Okay, and then look, if you added 12 over there, you would get 52.
Yeah.
Brandon?
Can you just do 1 divided by 4 and then multiply that by, divide that by 50?
Okay. If you do 1 divided by 4, that's going to give you a decimal, right? Yes. And that's what I was saying about decimals, is that this case, this 1/4, that's a pretty decimal. Do 2 divided by 3 and try doing the same thing, and it's going to be really
0.33
ugly.
repeating.
It's going to be 0.66666. Repeating.
Don't
Okay.
any sixes.
Olivia?
I'm very confused because
Okay.
God,
I just like looked at it, and then if you add 3, it's 13,
Mm-hmm.
and then, oh,
You see it? Okay.
I didn't add the 3.
That's okay. All right, let's take a look at number 2. So what would you start with in number 2?
-7.
Okay, let's minus the 7 first. So minus 7 minus 7. So I get 2/3 x equals 12. Now, Liz, this will answer your question. Because this time when I go to multiply by the reciprocal, what is the reciprocal now?
3
3
halves.
halves.
3/2. So it's not just a single number. Okay, 3/2 times 3/2. This scares some people doing this multiplication sometimes. All this is saying literally is 12 times 3 divided by 2. So do 12 times 3 divided by 2. Should be, yes, 18.
18.
So x equals 18.
I think 12 divided by 3, or divided by 2, and then multiply that.
Oh, yeah, you could do it that way too. So you just did it in a different order. That's fine too. Yep. Yeah, you're right, because that makes the number smaller first and then goes bigger instead.
What
So
did you do?
he did 12 divided by 2 and then multiplied by the 3. That's
Okay.
fine, or you can do 12 times the 3 divided by the 2. Either way. Okay? Okay, so that third one has variables inside the fractions, and they're not even nice fractions that you can combine easily. Now, I'm going to show you something here, and you're going to fight me on it. You're going to say, no, my teachers have always taught me to find common denominators and combine the fractions. I want to show you a way to get rid of the fractions completely,
That's so fun.
because fractions freak me out.
Fractions are
Okay.
stupid. They should have never been invented.
So,
Yeah, whoever made
let's get rid of the fractions right off the bat. And it's going to sound similar to when you were learning how to find like a common denominator. What I need is the smallest number you can think of
2.
that both 4 and 2 go into.
4.
Okay, 4. Because 4 does not go into 2.
Yep.
Right? 4 does not go into 2, but 2 does go into 4. So 4 is my number. Now, technically, if you had chosen a different number that was bigger, this would still work, but it would just make your numbers bigger. So I try to go for the smallest one. But some people might look at that and think 8. Okay? So here's what I'm going to do. I'm going to multiply this entire equation right off the bat, kind of like we did up here, like Austin suggested. I'm going to multiply everything in this equation by 4. Okay? And here's what that's going to look like. Good. Very good. because this is really going to have me doing 4 divided by 4 when I multiply here. What is 4 divided by 4? 1. So now this is a 1x, okay? You can just write x, yeah. And then 4 divided by 2 is 2, so this is going to be 2x. Yeah, we will combine.
3x.
What you have to, that was going to be a really bad sentence. What you have to remember to do, what you have to remember to do, Austin, you forgot to do this thing that I'm about to tell you not to ever forget to do, okay? You have to multiply this 4 by the number on the end as well, okay? Because otherwise you've changed what you have over here without changing what's over here. Remember with equations you have to do everything to both sides? So 4 times negative 15 makes negative 60. And now I can combine, and doesn't that look prettier though? Isn't that way nicer than what it started with?
So it's negative. That's pretty.
Yep. So 3x equals negative 60, divide by the 3, divide by the 3, and x equals negative 20.
That's my favorite number.
Perfect.
Yep.
All right, I want to show you something with number 4. Number 4 has decimals in it. Now, in the age of calculators, decimals probably don't freak you out too much, right? I think I could put that in front of any one of you and you'd be just fine, right? But I want to show you something that you could do with decimals that sort of helps you if you were having to do this mentally, okay? This is sort of what I do in my brain when I'm doing problems up at the board. See how these all have just one decimal place? What would I have to multiply by to get rid of that decimal point? 10, right? Because it's 1 decimal place is 10, 2 decimal places would be 100, and so on. So if I wanted to, I could multiply this entire equation right off the bat by 10. And what that's going to do is just move the decimal 1 place over on everything. So this 0.5 is now going to be a 5. This 1.1 is now going to be an 11. And the 2.9 is going to be a 29. So that just makes that a little bit easier to do, especially if you were doing it like without a calculator. Okay? That being said, I don't care if you do that or not. All right? I would like you to write it down right now just so you have it to refer to. But if I gave you an equation like this, I think all of you would be fine just adding the 1.1 and going from there. Okay? Let's add 11. 5x equals 40.
8.
Divide by 5. Yep. And x equals 5.
8.
No, you're right. 8. Thank you.
Good job, Austin.
Yep, it is x equals 8. Did you do it with the decimals, Curtis?
Yes.
Okay, and you still got 8, right? Okay.
I got 2 when I did it with the
Okay, so let's see. What did you get when you did 2.9 plus 1.1?
4.
Okay, and then you divided by 0.5? Did you do that in your head or on a calculator?
Oh.
Okay. It's weird. 4 divided by 0.5 is actually 8. It gets bigger when you divide by 0.5. I know you're thinking like, oh, you're just cutting it in half. But dividing by a half is really like multiplying by 2. Okay? Okay, so the whole point of me showing you number 5 was sort of to show you what we did in the warm-ups today, that you could get rid of that 3 first if you wanted to. Now, would it be okay for you to distribute that 3? Sure, if you wanted to. I'm going to get rid of it right off the bat.
Me too.
Good.
Good job, Austin.
So I end up with 2x minus 1 equals negative 5. Okay.
Why did you use
Why didn't I distribute? I could.
Okay.
If I wanted to distribute, I could. Yeah. And then here I would add 1, 2x equals negative 4.
What?
Negative 5 plus 1? Negative 4.
X equals negative.
Divide by 2.
equals
You got it. X equals negative 2.
Lily had it before everyone.
Good.
It is amazing.
Let's
negative?
try.
In my head.
It's Marty.
Okay. Number 6. Now, there I've shown you how to just get rid of that number straight off the bat. Number 6, I don't really have a good choice but to distribute. Okay? Because I have numbers in front of the parentheses on both sides. So I don't have a good way to divide and get rid of that. Okay? Hayden, what would I get if I distributed that 4? What would this side look like? So I'm going to do 4 times 3x. What's that going to give me? 12x, yep.
Yeah, 80.
And then I'm going to do 4 times the 2 and get, there you go, negative 8. So this side's going to look like 12x minus 8. Good. Kaylee, can you tell me what this other side would look like? Sorry, other Kaylee.
12x plus 10.
Good. Distribute that to 12x plus 10.
Can you combine like
Sorry, I have to call you other Kaylee. I don't know last names yet. I've got first
It's
names.
little.
But, okay. Oh, that's right. Okay. Okay. Anyone noticing anything weird yet?
Yeah.
Okay.
they're both 12x.
When you have x's on either side, your next step is to get them together. And so we need to move one of the x's to the other side. Michaela, what are your thoughts?
So we divide by 12x.
Not divide.
Multiply.
If we want to move the whole thing, so let's talk about the difference here. If I was trying to get the 12 away from the x, that's when I would divide, okay? But if I want to move that whole thing, I'm going to subtract, yep. So I'm going to subtract 12x and subtract 12x. And look at this.
That- oh my
They're
God.
both going to cancel out, right? That's weird. That doesn't happen very much.
That shows negative 10 equals, or negative 8 equals 10.
You're right.
So it's
Fortify. Okay. For what values of x is this ever true? Never,
See,
right?
they're-
There's no way that this could ever be true. So this is a no solution, okay? There is no number that I could plug in there for x that would make this statement true. Because no matter what, you can't make that true. That only happens when the x's cancel out and you're left with two numbers that are not equal to each other, okay? We'll talk about what happens when your x's cancel out and the numbers are equal to each other in a minute, but that's what happens when they're not equal. Going well so far?